So our goal for today is to solve systems of equations using elimination. And the whole basis of this method is actually the golden rule of algebra, which tells us whatever we do to one side of the equation, we must do to the other. So what this has to do with is adding two equations together. And since the left side equals the right side, we can add the two left sides and add the two right sides, and we will still have an equation that is true. Our goal when we do this is to eliminate either an x or a y from the equation, because we can't solve an equation that has two variables. We need to get it down to one variable. And on my first example shows this. So I have x plus y equals 6 and x minus y equals 4. And what happens when I add these two equations together, which is one of the reasons it's called addition, because I add the two equations together, what happens is the plus y and the minus y cancel to 0. I have x plus x, so I have a total of 2x, and 6 plus 4 equals 10. I have eliminated one variable from my equation, and that's a reason it's called elimination. So it's either called elimination or addition, depending on what website or what book you are looking at. So now I have an equation with just one variable in it, and that makes it easy for me to solve. So in this case, I'm just going to divide both sides by 2, and I have x equals 5. That's all the addition I'm going to do in this problem. To find the y value now, or the other value, I need to use substitution. So I'm going back to our old friend substitution. I'm going to take either one of my two equations, so I have the first one here, and I'm going to substitute x equals 5 into that equation. So instead of x plus y equals 6, I have 5 plus y equals 6. And now I'm going to solve for y. So subtract 5 from both sides, and I get y equals 1. So my solution is 5, 1. And in my graph here at the right of these two equations, you can see that the point of intersection is in fact 5, 1. All right, so that's a very simple example of using the elimination or addition method. So let's try this again. We've got another example at the bottom of the page. We're going to do the same thing. We're going to add our two equations together. Now the important thing when you do this is to make sure that all the parts are in the same order in both equations. So make sure the x's are on top of the x's, the y's are on top of the y's, the equal sign is in the same place in both, and the constants are in the same place in both. If they're not the same, you've got to make them the same. Okay? So here's what I've got. I've got x minus 3y equals negative 1, and 2x plus 3y equals 16. And I'm going to add these two equations together. And what happens is the minus 3y and plus 3y cancels to 0. When I add my x's, x and 2x gives me 3x. Negative 1 and 16 gives me 15. Divide both sides by 3. And I have x equals 5. So another example of elimination. That's all the adding I'm going to do. Now I go back to substitution, and I take either one of these two equations. They're both going to give me the same answer for x. So I'm going to take this first one, and I have x minus 3y equals negative 1. And I'm going to plug in or substitute x equals 5. So I've got 5 minus 3y equals negative 1. I'm going to subtract 5 from both sides. I have negative 3y equals negative 6. Divide both sides by negative 3. And that gives me y equals positive 2. So my solution is 5, 2. And we can see from the drawing at the right that the point of intersection is in fact 5, 2. Now, here's the issue. Not all systems of equations are set up so nicely for us. Let's take a look at page 4, the example number 5. Now, if we look at these two equations, if we were to simply add them together, what we notice is that nothing eliminates. 2x and 2x is going to give me 4x. Negative y and 3y is going to give me 2y. Nothing eliminates. So I need to do something to make an elimination happen. What would be convenient is if one of these 2x's was negative. Then I would have negative 2x and positive 2x. Or if this y here was a 3y, that would make this more convenient. What I'm going to do is I'm going to get this so I have a negative 2x and a positive 2x. Out of the two options, I'm just choosing that. There's no right or wrong as to which option you choose. And for that reason, we all can take different paths to the end of this problem. So in order for this to be a negative 2x, I would need to multiply the whole top equation by negative 1. That means multiplying the 2x by negative 1, the negative y by negative 1, and the 4 by negative 1. Now, when I do this, I want to write or show my work so that my teacher understands what I intend to do. So what I'm going to do is write down my original system, and I'm going to draw arrows to the right here. I'm going to multiply this top equation by negative 1. So I'm writing multiply by negative 1 here, and that's what I'm going to do. So over here, when I multiply by negative 1, I've got negative 2x, positive y, and negative 4. I'm not doing anything to the second equation, so I'm not writing anything on top of this arrow. And I'm just going to move it over here the way it is. And now I'm going to add them. When I add them, the negative 2x and positive 2x eliminates. It cancels to 0. When I add my y's, the y and the 3y gives me 4y. Negative 4 and negative 12 give me negative 16. Divide both sides by 4, and I get y equals negative 4. That's all the addition I'm going to do. Now I'm going to do substitution. So go back to the substitution. Pick either equation, it doesn't matter which, and I'm going to substitute y equals negative 4. So I'll just take the first one. 2x minus y equals 4. And I'm going to substitute in negative 4. So this is 2x minus negative 4 equals 4. And minus a negative is the same as plus a positive. So this really is 2x plus 4 equals 4. And now I can solve that. So subtract 4 from both sides. And I have 2x equals 0. Divide both sides by 2. And it gives me x equals 0. So my solution is 0, negative 4, which is the point of intersection that happens to be in my graph. All right, let's try another one of those. So looking at example 6, I notice that if I just add these, I'm going to have 12x and 5y. Nothing eliminates. Now, if one of the 6x's was negative, then my x's would eliminate. So I'm choosing one of my two equations to multiply by negative 1. And I'm actually just going to choose the bottom one. And you could choose the top one, you're still going to get the same answer. So I chose the bottom one. So my top equation just has an arrow, and I'm going to write it the same way it is. My bottom equation, I'm going to multiply all three parts by -1. So I have -6x, positive 2y, and -12. And now I'm going to add. When I do this, the 6x and -6x cancel to 0. They eliminate. 7y and 2y gives me 9y. -15 and -12 give me -27. Divide both sides by 9, and I'm going to get y equals -3. Now I'm going to use substitution. So go back to either one of the original equations. It doesn't matter which one. I'll take the first one. So 6x plus 7y equals -15. And I'm going to plug in y equals -3. Seven times -3 is -21. So 6x minus 21 equals -15. Add 21 to both sides. And I've got 6x equals 6. Divide both sides by 6. That gives me x equals 1. So my solution is 1, -3. So far, the two examples where we had to multiply, we multiplied by -1. But you could multiply by anything. So let's go to the next example and show how we could choose anything to multiply by. In this example, if we just add the equations the way they are, we have 7x and -3y. Nothing eliminates. Now, if this happened to be a positive 2y, then the y's would eliminate. I can make this a positive 2y by multiplying this second equation by -2. So that's what I'm going to choose to do. My first equation is going to stay the same. So 4x minus 2y equals 10. And my second equation, I'm going to multiply it by -2. So I have -6x, positive 2y, and -24. And now I'm going to add. When I add, my -2y and positive 2y eliminate. They cancel to 0. 4x and -6x give me -2x. 10 and -24 give me -14. Divide both sides by -2. And this gives me x equals 7. Now I'm going to substitute, and I can use either one of my original equations to substitute into. I'm going to take the second one. So I have 3x minus y equals 12. And I'm going to substitute in x equals 7. So 3 times 7 minus y equals 12 gives me 21 minus y equals 12. I'm going to subtract 21 from both sides. And I have -y equals -9. I'm going to divide both sides by -1. And I get y equals +9. So my solution is 7, 9, in parentheses, or a box around it so you know where your solution is. All right, let's take a look at 8. The issue here with 8, if I add these two equations together, I have 7x and -y, so nothing eliminates. But if I look for one equation that I can multiply by something, I can't see anything that I could multiply to make an elimination. And that's going to happen sometimes. So it's going to require a little more work on your part when this does occur. What you'd have to do then is multiply both equations by something. Here's your options. To eliminate x's, we could multiply the top equation by -5 and the bottom equation by +2. That would give us -10x on the top, +10x on the bottom. So x's would eliminate. Or, and I could eliminate y's by multiplying the top equation by 4 and the bottom equation by 3. In which case I would have 12y on top and -12y on the bottom. And the y's would eliminate. It doesn't matter which of those that you choose. So here's what I'm going to do. How about this? Let's multiply the top equation by -5. And my bottom equation, I will multiply by +2. So I'll write my new equations below. So this gives me -10x, -15y, and sometimes this gives you large numbers. So it's good to have a calculator handy. 35 times -5 is -175. Now, keep in mind, as long as you don't make a math error somewhere, these will all work themselves out. The second equation, I'm multiplying by 2. That's going to give me +10x, -8y, and 14. And now I'm going to add these. The -10x and the +10x are going to eliminate. And I'm just going to have y's left. I have -15 and -8y. That gives me -23y. I then have -175 and +14. This gives me -161. And at this point, I'm going to hope that divides nicely by 23. So divide both sides by -23. And it gives me y equals 7. Now I need to do my substitution to get my other variable, the x. Go back to either of your original equations, and we're going to use substitution. So I'm going to go back to 2x plus 3y equals 35. And I'm going to plug in 7 for y. So I have 2x plus 3 times 7 equals 35. This gives me 2x plus 21 equals 35. I'm going to subtract 21 from both sides. This gives me 2x equals 14. Divide both sides by 2. And that gives me x equals 7. So both x and y happen to equal 7. And I'm going to write my solution, 7, 7, in parentheses, put a box around it so that my teacher can find it.